All right, so the second page of our notes, we have triangle mid-segment theorem. And we have the mid-segment theorem states that the line segment connecting the midpoints of any two sides of a triangle is parallel to the third and half of its length. So let's go ahead and come over here and label this triangle A, B, C. If I have a midpoint called X on AB side and a midpoint, let's call it Y on C, that is stating that if I have this line XY, that is parallel to BC, and it is half. So half of BC is equal to XY, or BC is equal to twice XY. Okay, and that's stating that theorem over there. So looking at this first problem, we have HG. That's what we're trying to find. H and G are midpoints. So we know HG is equal to half of the third side of the triangle, which is SU. And so let's go ahead and write that. HG is equal to half of 14. So HG is 7. And it should make sense that your mid-segment line, which is HG, is smaller than the longest side. If we come over here, we have RQ. Those are midpoints. So we can say that if I double RQ, that is going to equal the side IG. So if I double the side of RQ 6, that's going to equal IG, not IQ, IG. And 2 times 6 is 12 is equal to IG. And again, this side is the inside, that's the outside, and inside should be smaller than the outside. Okay, so you're either going to use a half, you're going to either half what you're given or double what you're given if you're given solid numbers to start with. The next two examples, you do not. So we are always going to double the small side. So we're going to double VW, and we're going to set it equal to the third side of the triangle, which is EC. So 2 times VW, and I'm going to put that in parentheses because I want to make sure I distribute that 2 to everything. So distribute 2, so I get 2x minus 10 is equal to x. Then I'm going to subtract 2x from both sides, and I get negative 10 is equal to negative x. And then my last step is to divide by negative 1, and 10 is equal to x. And you can check by putting, well, if I put 10 in here, 10 minus 5 is 5. And if I put 10 in there, there you go. So that would make sense for that problem. Coming over here to the next side, we'll find our midpoints, D and C. So we are going to double DC and set it equal to the side of the triangle, which is YW. So 2 times 2x minus 9 is equal to 3x minus 8. So if I distribute this 2 into both of DC, you get 4x minus 18 is equal to 3x minus 8. to solve, we're going to subtract 3x from both sides. 4x minus 3 is x. Negative 18 still, those go away. We get minus 8. Last step is to add 18 to both sides. So we get x is equal to 10. Don't always guarantee it's going to be 10, but these two examples, they were 10. Again, you can go in and solve, and you should see whenever you solve, this DC should be half the size of YW. All right, the very last thing that we are going to look at here is angles and with midpoint or mid segments. Since there are parallel lines, chapter 2 comes back, and mainly corresponding angles. Okay, so let's go ahead and look. If I have DE is the midpoint and BC is the sides of the triangle, those are parallel, and then I have this transversal AC or AB, then angles ADE and DBC are congruent by corresponding. And if I have this transversal, then AED and ACB are congruent. So it says highlight corresponding angles to the right. Hint, there are 6 sets. So if I'm looking over here, I have corresponding angle 90 and 90, and we can see that those are corresponding because I have, let's use a different, I have this line is parallel with this line, and then we have this line and this line, which are transversals and also parallel, and then we have our last little bit, this and here. So 90, they are corresponding. If I look off the green line, they are corresponding to one another off of those 2 lines. And then 90 right here, same color. If I have a 90 right here, that's alternating across the transversal, and 90 right there, which is also crossing that transversal. And I'll make that a little bit more noticeable in that color. Then we have 30 and 30 because they are alternating over, they're alternating interior as well. And then this 30 and this 30 are corresponding. And then the last thing we have is 60 and 60, those two are corresponding. Then this 60 is alternating interior, and this angle 60 and that angle 60 are alternating interior. And if you can notice as well, I have this side 6, it's 6 and 6, and then that would give you 12, and so the corresponding one inside would also be 6. And so you have all of those as well. You have the sides, you have the angles. So let's go ahead and manipulate this drawing down here with the information we have. We have x, y. X to y is 10. So this little side right here is 5. This side's 5. So that means B to C is also 5. If we know x to z is 12, so x to z is 12. So this portion and this portion is 6. So that means A to C is also 6. And then the last thing, if we know YZ is 14, Y to Z is 14. So we know 7 and 7, and we know this is also 7. So looking at the question, it's asking for AB. We just found A to B, and that is 7. And then it's asking for the perimeter of this little triangle right here. So I'm going to add all of those sides up. I'm going to add 7 plus 5 plus 6. All of that is going to give us a grand total of 18 as our perimeter. Then we can start looking at our angles now. So our angles in here, if angle Y is 63 degrees, then angle, this little XAB is also 63 because they are corresponding, and as you can see they're sandwiched between 5 and 7. So if we go here, there's 5 and there's a 7, so this angle right here is also 63 degrees, and then 5 and 7 is 63 because of the alternating interior, and I'm going to erase that and put that in there as well. So 63 right in here. And coming over here, that is one of the questions that was being asked. I think, where's this? ZCB, that is 63 degrees. Then let's go through and look at another one that they ask or give us. X is 75, so 75, and as you can see, it's between 5 and 6. So this is 75 degrees because that's corresponding. And then alternating, this is also going to be 75 because they are alternating across, and they're also sandwiched between 5 and 6. And then alternating as well, and that's one of them as well, is Z to B to C is 75 degrees. So I missed one over here. X to A to B is also 63 degrees. And then the last one we have to do a little bit of math for is they want us to find, let's do a different color. They want us to find Z. They want us to find this last little part right here. Well, we know this whole triangle, all angles in a triangle add up. So 75 minus 63. All the triangles add up to 180. If I subtract 75 and 63, angle Z is 42 degrees. And that's it.